Hello students, in this video let's start with our next chapter, exponents and powers. Introduction to exponents and powers. The exponents tell us that how many times number should be multiplied. It is called the exponential form. This is written like this. So if you see here 10 to the power of 9. Okay, so that means 10 is multiplied for 9 times. Okay, so we are in the previous chapter and all we learnt about square and cube. That means square means it is multiplied for 2 times, cube means it is multiplied for 3 times. So when you have numbers more than 3, so that time we can do like this. Okay, any base number. Okay, here the base is 10 and the exponent is 9. That means 10 is multiplied for 9 times. Okay, so as a whole this is a power. Here 10 is the base and 9 is the exponent and this complete number is the power. We pronounce it as 10 raised to the power 9. Okay, so how we should pronounce it? We should tell it as 10 raised to the power 9. Okay, the exponent could be positive or negative. Okay, so the exponent 9 is there, no? It can be a positive number like 9 or negative like minus 9 also. Okay, it can be either positive or negative. This tells us that the number 10 will be multiplied 9 times like. Okay, so like this 10 into 10 into 10 into 10, 10 into 10 into 10 into 10 into 10. So that means 9 times 10 is multiplied. Okay. So this is how we can write it. Okay, 10 raised to the power 9, where 10 is base and 9 is exponent. As a whole, it's a power. Powers with negative exponents. The exponents could be negative also and we can convert them in positive by the following method. So suppose you are having a exponent like this, 100 to the power minus 3. So if you have minus 3 as exponent, so how we can change it into a positive exponent means we can write like this. So 1 by 100 to the power 3. Okay, so this is how you can change from negative to the positive. This shows that any non-zero negative integer a, so this is a common form. Okay, so instead of number we have written in the form of a and m. Okay, a to the power of minus m, then we can write it as 1 by a to the power m, where m is the positive integer and am is the multiplicative inverse of a to the power of minus m. Okay, laws of exponents. If we have a and b as the base and m and n as the exponents. So these are some of the laws of exponents. It's very important. So with this only you will get the problem. So this is very important. You have to keep it in your mind. Okay. So a and b are the base. Okay. So m and n are the exponents. If you see here, a to the power m into a to the power n. Okay. That is equal to a to the power of m plus n. Okay, so here both the base are same number a. Okay, only the power is different. Then you can add the power together keeping the base as same number. Okay, so a to the power of m plus n. Then you can see the example here, 7 to the power 3 and 7 raised to the power 4. When it is multiplied, so what you should do? So you should keep this also in mind. So here they are in the multiplication. Okay, so here these two are multiplied. So we can keep the base same, that is 7. And power should be added, that is 3 plus 4, that is 7. So 7 raised to the power 7. Okay. Then a to the power m, then whole power n. Okay, then in such case we have to multiply those two, now m and n. Okay, So actually here it is missing, but in the example you can see here. So 7 to the power 3 and whole power 4 is there. So what you should do, you should multiply both the powers. Okay, power of power means you have to multiply. Okay, 3 into 4 is 12. So 7 raised to the power 12. That's the answer. Then next law is a to the power m divided by a to the power n. Okay, instead of first law is multiplication. No, here it is in division. That's the difference. So in multiplication we added the power. In division we will minus the power. Okay. So 7 raised to the power 4 divided by 7 raised to the power 3. Then what you should do? You should minus the powers. So 4 minus 3, that is 1. So 7 power 1, that is 7 only. Okay. Then a power m and b power m. If you see here, the base numbers are different. Here it is a, here it is b. Okay. But the power is same. Power is both are m only. So what you should do? You should take it as ab to the power m. Actually here it is m. It's a typing mistake. So it should be m only. Okay. So you can see here in the example. So 7 raised to the power 3, 4 raised to the power 3. Here the base numbers are different, but the powers are same. So what you should do? You should multiply the base number. Okay. So 7 into 4 you should multiply and put the power commonly as 3. Okay, both are having 3, so you can put 3 as the power. Okay, so you will get 28 raised to the power 3. Then a raised to the power 0. Anything power 0 will be 1. Okay, so any number raised to the power 0, then the number, you will get the answer as 1. Okay, 7 power 0 is 1. It can be any number. 100 power 0 also 1 only, no problem. Any number it can be, anything raised to the power 0, you will get result as 1. Then a to the power of 1. Anything power 1 is the same number. Okay, so only one time you are having the number. Okay, a to the power 2 means what you will do? A into a you will write. Here a to the power 1. That means simply a only it will be there. So 7 raised to the power 1 is 7. Then 1 by a raised to the power n. So we already saw, no? So when 1 by like this it is there means, that means the power is in negative. Okay, we saw in the previous slide, same way. 1 by 7 cube. So you can write it as 7 to the power minus 3. Okay. Use of exponents to express small numbers in standard form. Okay, so small numbers. Sometimes we need to write the numbers in very small or large form, and we can use the exponents to represent the numbers in small numbers. Okay, so if you see here, so I'll go in reverse. Okay, so this is a very big number. Okay, so 2 you're having and 9 zeros you're having. It's a very big number. So if you want to represent it in a small number, then we can use this method. So how many, so from 2 you are taking. Okay, so 2 you want to write here. So rest all you want to put it in the power. So count the number of places. So 1, 2, 3, 4, 5, 6, 7, 8 and 9. Okay, so 9 places it is jumping. So you can take everything together as 10 to the power 9. Okay, so 2 into 10 to the power 9. So big number. Okay, this is a very big number which can be represented with a small number and a exponent. Okay, so similarly, standard form to write decimal numbers like 0.0000, so on to xyz. So any number xyz you are having at the last. Okay, it's a decimal number which is very, very small. Okay, so 0.000 is very small number. So that number you have to represent it. Okay, so that in that case what we can do, we can write like this. Suppose this also will go in the reverse. If you see here, this is our number. Okay, so 0.000002 you're having. Okay, So this small number we have to represent it in a comfortable bigger way. Okay, so what we should do, we have the steps also, I'll explain you. So what we should do, we have to, how we counted in the previous slide, same way you have to count the places. So how many decimal places you are jumping towards the left. Okay, so that many numbers you have to raise the power. Okay, so here you are having everything as 0. So then you can write it as 10 to the power minus 9. Okay, a smaller number you are writing it as a bigger number, then you should use exponent in minus. Okay, in the previous slide we saw a bigger number expressing as a smaller number. That time we used the exponent positive. Okay, this thing you should keep in your mind. When should use the positive number and when to use the negative. So smaller number to bigger number, you will use the negative sign here. Okay, so first step, first of all, count the number of digits from the decimal point to the last digit. Suppose this is your number, means from decimal point how many decimal places that number is present. Okay, that's a valid number is there at the 9th place. Okay, so that number we are counting. If there is only one digit after the zeros, then simply write down that digit. So here in this example we are having only one number which is a valid number. Okay, rest all are 0. So only one number you are having. So what you should do, you should write that number. Only one number is there, that number you write it. Place a multiplication sign and write down the counted digits in first step with a negative sign as the exponent to base number 10. Okay, so we saw that only one number is there at the end, that is 2. So write that number. So how many decimal places you counted in the first step, that number you should write it in the negative. Okay, with the base as 10. Okay, this is in the case of a number with decimal, after the decimal only one number is there at the end, rest all 0. In that case we can use this. If there are 2 or more non-zero digits at the end of the number. Okay, so in this slide I showed you, so any number like XYZ. Okay, here only x is there, that means 2 is there. Suppose you are having 3 numbers like this. Okay, instead of only 2, you are having 2, 1, 3, like that any number is there. Okay, then what you should do? Then write down the digits followed by a decimal point after the first digit and the other non-zero digits. Okay, then now calculate the number of digits in the first step and minus the number of digits appearing after the decimal point. Okay, so first step, how many number you counted. Okay, that number you should minus from the digits. Okay, suppose 3 digit is there, means so after that you can minus the 3 digits. Okay, so place a multiplication sign and write down the counted digit in step 4 with a negative sign as an exponent to base number 10. Okay, so this is how you have to do for the number which is having more than any valid number. That time we should use this. Comparing very large and very small numbers. So for that we should make the exponents same. Okay, so let's take the example, then you can understand better. So if you're having here you have different exponents, 8 here, 7 here. So you have to change into either both 8 or both 7. Okay, so if you see here it is 8, no? So in order to change this as 8, what I'm going to do, I'm going to jump one decimal point inside, okay, towards the left. So I'll have exponent as 8. So now it is very easy to compare which is bigger, which is smaller. Okay, so with this I'll wind up this video. So I'll continue the same in the next video. Thank you, children.